Hello guys, welcome back. Today we're going to continue to talk about confidence intervals. Last time we saw how we computed the confidence intervals for a population mean when standard deviation of the population is known. So today we are going to see how to compute the confidence intervals for a population mean when the standard deviation of the population is unknown. So in this case we're going to use the t distribution instead of the z distribution as we used the last time. Okay, so objectives will be to find the critical value, to find the standard error, margin of error, and of course the confidence interval. Now if you look at the formula, you're going to notice that it is similar to what we had when we knew the standard deviation of the population. The only difference is that the critical value now is the t distribution. We're using the t distribution instead of the z distribution. Okay, so you have t alpha over 2, the critical value, and then now you can see that for the standard deviation part, we use the population standard deviation when we knew the population standard deviation. But since we don't know the population standard deviation, we're using the sample standard deviation. Okay, so the margin of error is still critical value times the standard error. T alpha over 2 is the critical value, S over square root of n is the standard error. Okay, so this is one way we can express the confidence interval, the lower bound on the left and the upper bound on the right. This is another way to express that. Okay, so when you add or subtract the margin of error from the point estimate, you get the confidence interval. While the table below shows you how the definitions of some of the terms we're going to use. X bar is the sample mean, T alpha over 2 is the critical value, S is the sample standard deviation, N is the sample side, and so on. In this case, we're going to use a degree of freedom. So we go down here with an example, and the first thing we're going to do is to find the critical value for these levels of confidence: 80%, 90%, 95%, and 99%. Just like we did before, we're going to use inft instead of invnum to find these critical values. Okay, so to calculate the critical value, the long way to do this, first of all, if you look at E, the confidence level is 80%, so that tells me that alpha is 20%. Okay, and 20% is the same thing as 0.2. Okay, that's 1 minus 0.8 is 0.2. Therefore, alpha over 2 is 0.1, and then we subtract 0.1 from 1, that gives you 0.9. Okay, so the degrees of freedom is always sample size minus 1. So in this case, degree of freedom is 64 minus 1, which is 63. So the t value that corresponds to area of 0.9 is the critical value, and the answer is 1.295. So let me show you how to get this critical value for the t using TI-84. So you turn this on and you go to second verse, and then you're going to select number 4, which is inft. That is what we use to find the critical value for the t distribution. So when you go to the calculator, what you put in here is 1 minus alpha over 2. Okay, so for the area, 1 minus alpha is 0.2, so I'm going to do 0.2 divided by 2. Okay, so that's how we put in area when we want to find the critical value. Then the degree of freedom already we said is 63, and that is 64 minus 1. And we'll go to paste, do that. So you can see how we got 1.295. 1.295, that's our critical value. Okay, so you can do 1 minus alpha over 2 is 0.9, then you have comma 63. Okay, so the next thing we're going to do is to look at the confidence interval. All right, now we have found the critical value. The next thing is to find the confidence interval. Okay, so you can look at this table. Alpha is 0.2, alpha over 2 is 0.1, the alpha minus and that's the same thing we just did to find the critical value. So to find the confidence interval, we're going to illustrate using this example. Okay, a sample of 64 students uh, has a mean of 6.2, sample standard deviation 1.2. We want to construct the confidence intervals for the population mu with the following levels. So we're going to just give one example, and 80% first. Okay, so if you look here, this is the example 80%. The sample mean is 6.2, and remember we got the critical value to be 1.295. The sample standard deviation is given in the question as 1.2. Okay, and then we have n as 64. Then the standard error is remember is sample standard deviation divided by square root of n. So that's 1.2 divided by 8, which is 0.15. So this is our standard error. Therefore, margin of error, remember margin of error is standard error times critical value. Okay, so our margin of error is going to be 1.295 times 0.15, which is 0.194. So if you want to get the lower boundary for the confidence interval, you just do the sample mean minus the margin of error. Okay, so that's 6.2 minus 0.194, which gives me 6.005. Then to get the upper boundary, you're going to take the same sample mean and add the margin of error. In this case, we get a value of 6.394. So this is this confidence interval. The lower bound is 6.005, and then the upper bound is 6.394. How do you do this using the TI-84? We're going to go to Start, and we're going to go to Tests, and we're going to go to T-interval. T-interval is number 8. Okay, so we'll enter, and we're going to select Stats because we have the values we need, and then we have the sample mean as 6.2. The standard deviation of the sample is 1.2, n is 64, and then the confidence level in this case is 0.8. Okay, so go down and calculate. So you can see now that the first output here is the confidence interval. It tells us that the lower bound is 6.005 and the upper is 6.394, just like we got right here. Okay, so when you do this, the confidence interval shows up. It tells you the sample mean, the standard deviation of the sample, and of course the sample size. Okay, so that is how we obtain the confidence interval when we do not know the sample, the population standard deviation. Okay, again, we did this by hand here. Okay, so in this particular row, we showed you how to compute this by hand. But if you want to use the TI-84, which is quicker, faster, you just follow the steps we just took. Okay, so that is it for the confidence intervals using TI-84 and doing it by hand when the population standard deviation is not known. Okay, so next time we're going to talk about something else. Make sure you try to do the 90%, 95%, and 99%. All right, thank you, and see you next time.